everyone, welcome to the class of reservoir simulation. Today we are going to talk about the Eclipse Office software, which is used for widely for reservoir engineering calculations. And First of all, we need to learn that what is Eclipse. Well, Eclipse is a reservoir simulation software, and it's used widely in reservoir engineering and by the reservoir engineering team. Well, it's a three-phase. This software actually we talked about it that we have three phases: oil, gas, and water. So it talks about three phases, three dimensions: x, y, and z. And it's a general you can use for many applications, including from production predictions and so on, and many others. Well, it's written in the Fortran language, and this subject we are talking about the Python. But originally, this software was written by the Fortran, and it can work with anyone. It can simulate any phases: one phase, two phase, three phase. It has both options, the compositional option and as well as the black oil option. Okay. Also, it can model the vaporizing in gas and oil and so on. It also has 3D radial option and Cartesian block center. So all options it has, and it's quite a modern software that is used nowadays in oil and gas industry. So the first question is how to start. Okay, how to start with reservoir simulation? How to start with this software? Well, first of all, to run this software, we need an input file with all the data, concerned reservoir and process of an calculation. So we need an Eclipse file, and the extension of this file is actually the data. It has the file name .data. This is how you get this file, and I will show you right now in file and see how I can run it also at the same time. So now you see that I have a file here, SPE miscible. If you go to the properties of this one, it's .data. This extension is .data. So you open this file. Now you see that we have a file, a long file for Eclipse Office. Whatever simulation we do based on our programming here, based on this one. We start from. So we will talk about this file. For example, what is this grid? What is this equals here? What is, so we have to learn each keyword. What does it mean? What does it mean? What does it mean? What does it mean? And so on. We have to understand that what is going on here in all the data file here, and it comes with experience and by spending time on this software. So this was the data file that I showed you. We play with data file and then we run it, and I will teach you how to run this one, but today our objective is just to look into this data file in much details. Okay, now this data file has many options. It has eight sections, and each section you have to have lots of information that you need to put, lots of data that you need to put into it. So here are they. We have a Runspec section, we have a grid section, edit section, props section, region, solution, summary, and so on. 3, 6, and 8 sections that we have here. And they must be specified in order. Like Runspec from the top cannot go to the bottom, and schedule from the bottom cannot go to the top. So they has to be in order, and we have to remember them, and we have to remember their functions. Now I will show you that how actually. Now if you look at this data file, you see it's written Runspec. Exactly, you see here, this is Runspec, here is Runspec. This is the first section. Second section, you see this line, it shows that the section is ended here with the slash, and now you see it's grid here. So here you see that we have the grid one. So now if you go down further, you see now we have props sections. So if you look at it here, we have a prop section. We don't have the edit here. Usually we have Runspec, grid, properties, prop section. Then if you go down further, we have here the solution section. So here we have prop section, solution sections, and then we have the summary and schedule. It's not necessary that all of them should be there. but these are the one we are talking right now. They should be there: solution, summary, schedule. Each section, it has to be there. These are the time steps scheduled for this one, this file. This is the final file that we have. So we talk about one by one what are those. So for now, just remember that it has all this section, and we have to fill the data whatever we have in all those sections. Well, yes, status required. Well, run spec section is the basic section. It tells us about the title, the what I mean, the names, how many phases it has, it is black oil or compositional, and so on. The basic thing. Grid talk about the basic reservoir geometry, as you see here. As you see here, talk about the basic geometry of the simulation and various grid blocks. This is what the grid is talking about porosity, for example, permeability, net to gross ratio, each grid cell. So grid basic about grid information, Runspec just the basic introduction, name and title and so on. If you go ahead, we have the edit section. So this is optional. Okay, normally we don't use it, but with this prop section, rock and fluid properties for relative permeability, capillary pressure, viscosity, all this information, properties of rock is usually given here in the prop section. Then we have regions. Okay, region depends on with sometimes the reservoirs are not uniform. So what we do, we divide the reservoir into regions. Region 1 or region 2. Region 1 may have different porosity. Region 2 may have different porosity. So depends on this. Then we divide into region. It is optional, not always available, but this solution is required because the initial conditions may be needed. Calculated using specified fluid contact depth, and so the initial condition are given in the solution, like what is the initial pressure of reservoir, initial temperature, how much is the initial oil saturation, gas saturation, or whatever. So here you can see pressure, saturation, composition of initial you have to define. This is then we have the summary. Summary tells us that what results you want. This is optional, means you don't need to put all the uh, things you need. There's a lot of summary we can be generated here, but at least some of them are compulsory. For example, field oil production rate, field total production in 10 years, and so on. So we have to put all the information about the summary here. Then we have the schedule section. It tells us that how many wells it has, and how, till when, what time it will run, how many years they will run, and so on. So now this is the data file, and let's compare it with this, the data file I have here. If you look at it, you see now we have the title. So title of this one is SPE fifth comparison test problem. You can change it. Let's say class of simulation. Any title you can put it here. Dimensions. Well, as you remember that the each well, we if we have the big reservoir like this one. Okay, we divide into the small parts. Okay, for example, we convert them into like this into. So we have the big reservoir. We convert into the small blocks. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is telling those dimension of those grids. How many this this 7? How many in x direction? How many in y direction? And how many in z direction? So it tells us that, for example, here in x direction we have 3, and y is 3. So it here you can write here 3 and 3, and so on. Then we have to mention the phases: oil, water, what your reservoir that you are dealing with, what it has. So it has oil, it has water, it has scale. Then after that, this keyword field that you see here is actually the unit, which some field unit, which field system you are using, which unit system you are using, field, or you have metric, or you have the lab. Usually the field is the one which is used in this one. Then this is the special keyword used for the miscible, and here we will not talk about it because this is a special keyword used for SP miscible flooding, and we will talk about it when we solve the case studies. Then we have the well dimension. It tells us that in this simulation how many wells you are going to put. For example, 3 wells, and how many groups it has. All are grouped in the same way? Yes. So we have to put this information, and so on. Then this is the start date, when you are going to start. Okay, and the it tells the what kind of output you need. Indicate what output you need here. So title, number of blocks, oil, water, gas. Start date of simulation, data checking only with no simulation. So this is the basic run spec section we have. This was the run spec section. Now we go for the grid section. Yes. Okay, we will stop it here and then we will go for the second round for this lecture. So if you have any questions, you can discuss with me.